And
we are live.
All right, cool. And you can see me. You can see my screen.
Yep, we're all good.
All right, perfect.
All right. Welcome everyone to our last but not least talk of our conference. I have with us Jean Yang, and she'll be speaking on how to make developers happy and eat your API cake too. And I'll turn to you.
Yeah. Thank you. I'm Jean, and I know my title doesn't make a lot of sense. It's based on one of my favorite English phrases that make no sense to me. But I'll be talking about dev tools for APIs and how helping developers can help security as well. And I've never used StreamYard before, but I can't actually see myself. So if I'm making some really strange faces during my talk, you can just feel free to let me know on the Discord. So I have no clue how many people are actually watching. I have no clue how you're feeling about this talk. So please use text as much as possible. So apparently you can comment on the YouTube stream itself. And so any comments there, I believe, will be funneled towards me somehow magically. And if you just wave hi even in the Discord so that I know you're there, I will tailor my talk towards whatever you're doing. And so I when I give talks in person, I really like my talks to be very interactive. So yeah, if you just want to like reply with an emoji in the Discord, please do so. If you have any questions, any comments, anything, you're not bugging me. I actually loaded the Discord on a separate monitor so that it's its own process. And I'm really looking forward to experimenting with this form of engaging with you guys. So hold on, I actually only have one power cord, so I'm flipping it between my two. All right, cool. So let's start. You're probably here because you care something about APIs. And what I've noticed over the last few years is that there's this great discrepancy between the promise of APIs and what they actually do. So if you're an API consumer, people tell you it's going to be like being served breakfast in bed. People just deliver all kinds of wonderful functionality to you, and all you have to do is sit there. And if you are an API creator, it's just really nice. People can use your thing. You're just rolling in money and, you know, the joy of having created value for people. But the reality of APIs is like playing Jenga with charcoals, because what happens is if you are using APIs, any of the APIs can take you down, and you really have to be very vigilant. And if you are the producer of an API, you have to really be careful not to break other people's stuff. And so if you don't do anything with, so I guess most of you, I presume, are security people. And so to build some developer empathy here, if you don't already have it, like if you're a developer, it's hard enough making sure your change doesn't break anything. It's even harder if your developers are developing for a bunch of other people, and any of their changes could break a lot of downstream changes as well. And thank you for the ice cream cone emoji. I see it. I acknowledge it. Please, everybody else, keep making emojis in the Discord. And so this talk is really about a better way for working with APIs. The first part is, what are the current heroic efforts for keeping order with APIs? And if we zoom out a little bit, it's really about why modern web development is so hard, and what are the second order effects that affect security teams. And when I'm actually, I'll talk about myself in a little bit. I'll get to that part there. But yeah, the first part is like, why is life so hard? And the second part is, well, it's hard because our existing tools have forsaken us, and here's why. And then I'll talk a little bit about why I believe that modeling API behavior is the way. So if you guys are security people, you probably have heard of or used static analyses. You probably have heard of or used API testing, API scanning. I think these are all useful. They all map out parts of your system. But what's missing is this API graph. So what are the interactions across all the APIs? Like, what are the APIs actually doing? And so this is really a new way of looking at software that I want to get out there and have more people think about. And so for a little bit of background about me, I'm Jean. I work on programming tools. So before my current situation, I was working on programming systems and tools in academia. I was an assistant professor at Carnegie Mellon University, 2016 to 2018. I was a PhD student before that. I was publishing in pretty standard programming languages venues. You probably haven't heard of them, like Principles of Programming Languages, Programming Language Design and Implementation, International Conference on Functional Programming. And so these were all like language design, static analysis, verification conferences. Through all this, I came to believe that we needed tools at the API level, that the language wars have been fought, they've been won, and that really we needed system level tooling. And so in 2018, I started Akita Software, which is the company I'm running today, to do this. And we started out as an enterprise security company. We've shifted and generalized ourselves to becoming a dev tools company. And I'll talk a little bit about that path, but don't worry, this talk is for you, for a security audience. So since this is a virtual talk and I have no clue where you guys are sitting or coming from, you can also feel free to send pictures of your setups to the Discord if you're comfortable with that. I thought I'd just share this is my desk. This is where I'm coming from. This is a bit of an old picture. I had that very large bottle of sriracha at the beginning of lockdown. I ate my way through part of it, and then it got some gray fuzzy stuff on it, so I had to throw it out. But you know, this is otherwise my desk. It's a little messier today. But yeah, I since I can't see you, you can get the full picture of me at least. And I just wanted to give a little bit of an overview of my background in programming languages and security before moving on. And so a lot of the background I come from is like pretty traditional, like program, like how do we know our programs do what they're supposed to do? And how do we know they don't have like dangerous bugs? And a lot of those dangerous bugs happen to be security vulnerabilities. And so that's sort of how I got there. So the first paper I ever published was about verifying, building a verified operating system that you knew had type safe guarantees. So you never have memory errors of a certain nature. That got me into thinking, well, what else can we make as solved of a problem as memory safety? Could we do the same for like access control, information flow policies? And so what I did grad school on was a programming model that abstracted out access control and information flow security policies out of the program, did automatic enforcement, and I built a little DSL for doing this in Python. I started building web apps using this. And this is what led to my interest in APIs. Because what happened was I called out to the database as one of the first things in testing my language for building web apps. I was like, oh shoot, I made all these guarantees for my language, but they don't hold when they go to the database. And the generalization of that is in a modern web system, whenever you call, whenever you make a remote procedure call, whenever you call out to another runtime, you actually don't have any guarantees anymore. And so you don't have to understand most of what I'm saying to understand why I'm telling you this, which is I was doing a lot of language level stuff. I realized that languages are a really tiny part of modern web systems. And so I got really into what happens when components interact, what really happens at the boundaries, because that's what matters. And that's what got me into APIs. And so a couple years ago, I talked to everybody on my LinkedIn because I was like, I think APIs are the thing. I started Akida to do this. I spent a lot of time talking to developers at the beginning just to understand what I wanted to do. And so this led to like a lot of change in all of my assumptions about what actually matters when building programming tools. And so some of this talk is really like what I learned about the interaction between security and developers and how that motivated what I'm doing today. So let me just check really quickly if anyone is typing in the Discord. There's still only the ice cream emoji. I invite you guys to send more emojis. Cool. So let's start with what's hard about web development today. So I'm going to open with this case study about impact analysis at a company called Shopify. So Shopify put out an API a couple of years ago, and they have this fantastic blog post about how to do change impact analysis. And so the problem setup is Shopify, they have a lot of developers. They're updating their code all the time. And whenever they update their code, they want to know that they're not breaking any contracts with their API community. Because if they break that contract, their customers can't use their API anymore, and their customers are unhappy. Shopify's reputation gets damaged, and they lose money. And so I got very interested in change impact analysis because I saw that it was a generalization of what security cares about, which is did anything break in a way that can cause the system to get attacked or cause a data leak? So that's a side note that I'll come back to. But here, what I found interesting was basically at Shopify, people were going through and marking breaking changes by hand. So whenever they made a change, they'd say, oh, this is a breaking change or this is a possibly breaking change. They would instrument their systems, and then they would actually go through and generate these metadata reports of what API endpoints were affected by every single change. And so people have asked me before, well, can you just give us semantic versions to your API? And the answer is they couldn't figure out their semantic versions even without doing this manual propagation and instrumentation combination. And this was such an important problem to Shopify that they would deploy people to go out and interview their users if the change looked like it could cause people's code to break. And so why is this interesting to me? Well, it's interesting to me for a few reasons. One, breaking changes matter so much to Shopify that they're willing to put in all this developer and developer relations work to make sure that they don't happen. Two, this is such an important problem that they're doing a lot of manual work, but there's actually no automation around it. And three, this is the kind of work that I saw a lot of analogies to when I was looking at how people do security review for their systems. But there was not the same, that we're going to lose a lot of money. We're going to actually interview developers about this. And so initially how I got interested in this was I was trying to help developers with security code review. And I saw that if you could automate some of these aspects, it would be really, really cool because it would help everybody across the board. And so here are some examples of what Shopify considers to be breaking changes. And this is interesting to me because on the one hand, there are things that happen all the time. So things like changing existing error response codes messages, modifying the expected payload of webhooks and callbacks. Pretty much if you're a developer and you develop, you make changes like this. Otherwise, it's pretty hard. You're really stepping on a tightrope to do this development, changing the data type of a field, renaming a field, etc. And so there are all these things that are pretty small on the one hand. And on the other hand, they're all things that are pretty hard to automatically catch. And they seem like they should be easy to automatically catch, but they're hard. And so I'll talk about why this is in this talk, and then I'll talk about how we can catch it better. I acknowledge there's a second emoji in the Discord. Thank you. Please keep sending me emojis so I know I'm not just talking to myself with a microphone, which is also something I do sometimes. But it's always good to feel that that's not the case. But yeah. So this I became really interested in the Shopify blog post in particular because if there's one thing we know in software engineering, it's that we can ask developers to do things once, but if we ask them to do things over and over again, this is error prone and we should probably automate it. And for the Shopify solution, they had a really nice manual process, but they're asking developers to do the same thing over and over again. And so this very much collided with what I was trying to automate. And so I love bringing up this example. And so now let's look at why it's really hard to automate the mark breaking change, mark possibly breaking in the instrumentation. So the first thing we can look at, which is the primary vehicle for understanding code changes still, which is source diffs. And so you probably know as well as I do that diffing source code only goes so far when code hits a certain scale. Like even you could even have like a 15-line program, but as soon as it depends on even external libraries, there are subtle interactions that make it so that you need some knowledge of what everything does in order to make sure that nothing bad is happening. And then if you think about as soon as you're calling out to third-party SaaS, if you're calling out to your Twilios, your Stripes, this starts making things really, really hard. And then people might say, well, what about tests? Why don't we have tests that tell us if breaking changes are happening? And so especially if you're a security engineer who has done security code review, and I ask you the question, do you expect there to be tests to cover the cases you're interested in? The answer is probably no. This is true also more generally of most breaking changes out there. So the kinds of things that I talked about on the Shopify blog post, they're interesting because they're small enough that you often don't have tests for any little thing. And then I mentioned this briefly before, but there are static analyses, there are scanners. Why aren't they giving a picture of what's going on? And so I'll get more into this, but essentially what we have in modern software systems is we have this complex ecosystem of a lot of components that are all talking to each other. And any individual software analysis only analyzes one component at a time. That's a pretty zoomed in piece of the whole thing. And any scanner is usually focused on one edge between two components at a time. And so again, it's not giving you this whole graph. And so the dream is to have automated software tools that really fit our modern web apps and that really fit what I call the software heterogeneity problem. And I'll explain what that is. But before that, I'll just summarize. Great question. So Kyle says, unit testing, what's that? Rolls code changes into production on a Friday at 4:55 p.m. Yes, Kyle, thank you very much. So I think that when we started out, we were building a tool that runs in test, and the interesting thing we saw was we would tell people, oh yeah, you just run this in your test environment. And we weren't surprised about how many people said, well, we actually don't really have a test environment. And we're like, oh, don't worry. You shouldn't. I mean, like, I guess you can be embarrassed, but this is really, really common. But yeah. So to summarize the state of API efforts in the present day, you have external APIs that companies with the resources to spend on it. So if you're at a Shopify, Stripe, or Twilio, and you know that like 100% of your money that you make comes from your API, then you might do this really disciplined thing where you're tagging all your possible changes by hand. You've instrumented your whole system to track them. People are reading the reports that get generated. But I chose this picture of a facade in a parking lot because look, that's like one part of your system. You had to do it by hand. It like the rest of your system is just kind of, parking lot with weeds in the background. And so for better or for worse, that's what most developers are dealing with. If they're dealing with internal APIs, calls out to other APIs, like pretty much like, the majority of modern web programming. And this is also what's causing security engineers a lot of pain, because what I notice when I talk to security engineers is what you guys are dealing with is a major lack of visibility into what's going on and like a long path to like anyone telling you what's going on. And so I'll get to this towards the end of the talk, but I think we can rising tides lift all boats or whatever, whatever that phrase is. So, the next section of this talk is about why existing tools have forsaken us. How did we get left in a parking lot full of weeds? And the reason is that there are just more and more APIs everywhere. APIs, like I said, they promise to be great, but they're really causing a lot of problems. So from the Rapid API Developer Survey, if your company is 5,000 to 10,000 people, your average number of internal APIs is 307.42. And so that is a lot of parking lot weeds APIs to be dealing with internally. So this is stuff no one is manually calling mark breaking on. If there's a change in an error code, if there's a change in a payload, if there's change in a data type, no one is manually telling you that this is what's wrong. And so when a data format changes to something sensitive, when a payload changes to something you should care about, when something is getting an input from the internet that could be taking your system down, the security teams are not, like, developers, first of all, are not getting visibility into this, but security teams are really getting less and less visibility into this. And what these companies are approaching is this infamous Netflix Death Star situation here, where you have thousands, maybe tens of thousands of APIs all talking to each other, and you do not really have very much visibility at all into what is a breaking change. Cool question. So Jedi Timmy says, are the 300 APIs internal developers developed or includes all vendor APIs? So I believe, yes, the label says these are internal APIs. So this is internal APIs alone. If you count if you count vendor APIs, it is even more APIs that people are dealing with. And so, yeah, you really have major Death Star on your hands. And how I came to realize how hard this was I actually spent 3 years of my PhD modeling just one edge. So if we go back here and we're like, okay, cool. So you have 300 APIs. Maybe there's some way to just talk about how they all talk to each other. And so if we take the point of view from my training, which is, let's say we wanted to statically analyze the system. If you analyze one service of your system and you want to analyze how that talks to one other service of your system. To me, this was the paper I had written on analyzing how information flow dynamically occurred across a Python runtime and a SQL database. And it took us 3 years and this really, really complicated. So I put the most complicated page of Greek symbols on here, and Greek and other made up Unicode symbols on here to really model this is how you track your data across a Python runtime and a SQL database. And so when I saw the hundreds of services all running in heterogeneous runtimes, all talking to each other differently, I was like, okay, all of the methods that I've worked on before that have to do with analyzing software are just not going to work here. I don't expect you to understand this slide, but it's really, again, motivation for how I came to believe APIs were really important and you should stay at that level. And this is also a pointer. If you ever want to know why static analysis is not going to work for these modern microservice systems, I can tell you very, very precisely. So yeah, why automatically analyzing web apps is hard is because you have these web apps. They have many, many software components. And so if all the software components just ran one thing, let's say something pretty clean, like Java, that might be doable because you can treat it as just one big, really complex system. But first of all, these software components are running tons of dynamically typed, really wild, wild west kind of languages like JavaScript, Ruby, Python. They're all really, really hard to analyze from a understanding what the system does automatically perspective. And then the other thing is they're often running black box or different runtimes. And so even your internally developed APIs, if you have something in Ruby calling something in Node, calling something in Python, it's really hard to know if there's some interaction across those component boundaries that's going to cause things to break down. And then going back to Jedi Timmy's question, if you have vendor APIs you're calling out to, those are black box. You don't know what's going out to them. You don't know what's coming back. And so so you have this big mess of things and they're all different. They're all complicated. And so this is what I call the software heterogeneity problem. You have modern web architectures that defy both previous application level solutions and networks level solutions. So anything application level, you imagine like linting a piece of code for common security bugs, like that does not uncover your component interactions at all. Your static analyses, like that, like right now, the state of the art, I don't know if you use static analysis. I'd actually love to hear from you in the chat if you do. But what is going to happen with those is they'll give you like a very zoomed in thing, but like what data are you getting from other components? What are you sending out? How are the things interacting? You just don't know. And then if you think about your WAFs or your RASs or your API scanners, they're kind of sitting at one edge at a time. So people are getting more and more false positives because you're building these systems to collect credit cards, to collect all this PII, presumably because you need that information. So they're supposed to be in some parts of a system, but they shouldn't be in all parts of the system. But right now you can't tell because you don't know where data is coming from. You don't know where data is going. You don't know like even what part of the map you're in to know if the data is supposed to be there anymore. And actually, if you do, I would love to hear from you in the chat. And if you don't, you can just put some like exploding emojis or something. But the more I dug into this problem, the more I realized just how hard and how systemic the solution would need to be, and that it's really no one's fault that the visibility is getting worse, but we really, really need to fix it. Oh, cool. So Jedi Timmy says they have internal pen testers that check the APIs. Yeah. And so like something else we found was that pen testers, because like you're like humans can kind of hold a bunch of state in their head, like that is beating the automated tooling by a lot because there's like, you know, the limits of automation are pretty much everything I put on this slide. So yeah, that makes a lot of sense. Thanks, Jedi Timmy. And I would also say like once the system becomes like super, super complicated, a pen tester, like how are they going to come in and keep all of this state in their head? My solution is mapping things out automatically is going to help a lot. Cool. So right now, the result of the software heterogeneity problem is that developers are doing a ton of manual work to understand what's going on. So today, it's really expensive for developers to understand the impact of their code changes on others. And so like anytime a developer checks in any code change to a system like this, they are interacting with a lot of components that they don't know how that interaction happens. And you don't have to be the Death Star to do that. So we've talked with people who they they have a monolith, but they interact with a bunch of vendors, or their API gets interacted with by their customers, and that already is pretty common. And then understanding the impact of other people's code changes on them. So if you use a lot of other people's stuff, it's really hard to figure out what's going on. And yeah, Jedi Timmy says we found a lot of tokens and keys. Yep. So something we found that's a bit of a situation is people, if you're working on a service and you're just like, you're sort of one analogy I used to like to give, it's like you're a UPS delivery driver and you're getting these boxes. The boxes, you're delivering them places, but you don't necessarily know if the boxes are fragile or what they hold. And so like by default, you can't handle everything as if it's like, like holding like crystal or porcelain or I don't know, whatever is really fragile. But on the other hand, you can't just throw all the boxes around. And so, so if you're a developer and you're just like dealing with things like, so like what we found was developers were like taking whole user objects. They're just tokens places. People are passing around user object with password reset token, people passing around like, other tokens, other kinds of keys. And they just didn't even know because like, it's just data that they're moving from here to there. And so to complete the analogy that I started before, what we want to be able to do is be like, well, this is where the thing came from. This is where it's going. And here are some labels on the data to say like, this is fragile. This is flammable. This should not get wet. And so, yeah, so Jedi, to me, your responses are very, very validating. Thank you. And Yeah, the result of the developers not really knowing what they're dealing with is that security is lacking even more visibility. So for security, it's difficult to detect potential issues. It's also really hard for security to prioritize issues for developers to fix. So if we think about how we're in this regime where everybody is kind of like very zoomed in now. You have one service, the bigger picture is this really complex thing that nobody understands. So if you're like, hey, we found, passwords in this service, like if it's the password service, yeah, sure, maybe it's there. Maybe it's like, one service away from the password service. So it makes sense the passwords are in there. But without understanding how everything relates to each other, it gets really hard to prioritize like, okay, if the developer can only fix 5 of these, which are the 5 services that passwords really should not be in? And how do we fix that? And then it's also getting harder and harder to communicate with developers back about how to fix the issues. So if you think about what a static analyzer or what a scanner might do, it'll say, all right, we found some passwords, but like, what caused that? Where did the passwords come from? Like how might they even reproduce the situation that caused it? That's also getting much harder. And for us, that was a big motivation in us deciding at Akita to focus on building a dev tool to improve some of the prioritization and communication issues, rather than simply like sitting and scanning or something like that. And so we also what we learned about what developers want also led to a big part of what we're doing now. And so from talking to developers, we learned that getting a report of everything that could happen is not useful, since almost anything could happen. And so I don't know what kinds of tools you run, but you've probably had the experience where you turn on some kind of monitoring or you turn on some kind of analysis and it's like, yup, this sensitive data could go like all these places and most of them are bad. And you're like, yeah, I know, but it's not likely to go most of these places. So tell me what I should actually focus on. And what we learned was the more actionable the reporting, the more likely bugs are to get fixed. So the more it's like, yep, this is this is a bug, but here's a repro. And so we talked to a bunch of security engineers, for instance, that spend a lot of their time making repros to make things more actionable. And the closer it is also to the developer knowing how to fix it, whether it's from the actionability or from they just checked it in. I would say both of those feed into actionability from what we learned. And then finally, the easier it is to integrate the tool, the more likely it is people will try it in the first place. So if the gatekeeper for trying some of these tools is developers and they're using GitHub, they're using Circle CI, they're using all these other things, what we learned was we really had to imitate those workflows to really get some to get in there and get them to adopt us. And this is also what I don't know if this is things already, but when I've spoken at OWASP meetups, they've really liked this slide because a lot of security teams told us that they have discovered this is like their rule for what's an effective security tool as well. And so now I'm going to talk about the solution to all of this that I believe in, which is modeling API behavior. And how we model it, I think, is pretty nifty. And so if we want to model API behavior, so part of why I talked about my background was I'm trying to give you a sense of what I mean when I say model. And so I'm talking about not about machine learning models or like Cindy Crawford, but, like we understand what this code is doing. We have a spec for what the code does, and we know when it deviates from that spec. And so if we want to model what's going on across this interaction graph of APIs, we're going to need a standard way to describe what each service does. Thank you, Jedi, to me for appreciating the Taylor Swift gifts. If you find me on Twitter, by the way, I have a lot of threads about Taylor Swift. I didn't start out being a Taylor Swift fan necessarily, but she is very gifable. I can talk more about this in the Q&A. And then I got really into her music too, because I was like, I have so many gifts of her. I should start listening to this. Anyway, but what we will need, if we want to model these APIs, is we'll need a standard way to describe what each service does. We'll need a standard way to talk about how these services interact. And then ideally, there's some way to connect the specification back to the code. And so I don't know like what you guys think of when you think of specs. Like when I had to write specs in school, I was like, this is lame. When I had to write specs in the workplace, I was also like, this is lame. But then when I learned that you could actually use specs to like verify that your code actually does the right thing, or if you can, but even better, automatically generate these specs, and then like someone else can look at them and say, "Yep, that makes sense." Like that's really the sweet spot of the specs, I would say. But anyway, if we want to map out this graph, though, we need like some form of like, okay, this is what everything does and how it fits together, and so I got into API specs. So what I mean by API specs is like your Open API, your gRPC, or your Thrift, GraphQL. I got into them because I was like, they already are there. And they describe what services do. They are API specs. Like by definition, they're the interface specs. So they describe how the services interact with each other. And then because they're in name at least supposed to connect back to the code. So yeah. I got into API specs because I was like, well, we could, probably repurpose them for our API graph purposes if we did the right thing. And Chopper BZ said, not likely to go these places, so tell me what I should actually focus on. Yeah. Cool. So the rest of my talk is going to be about how and why we are where we basically have hijacked API specs to describe the API graph. And I'm really excited about this way of doing things. So I'm going to tell you about it. And then hopefully there are like interesting takeaways for your life too. Like maybe you'll use what we're doing, maybe not. Like this is not a vendor pitch. I'm mostly like, hey guys, there's this, I think there's this new way of looking at API traffic and API specs. And I think it's helpful. So our insight was, people have been doing a lot of analysis on programs and program traces. What if we just analyzed API traces and API specs instead, and use that to understand this API graph? And so the catch is that API specs are not actually easy to come by. Like they're not the sexiest thing ever. They're kind of annoying to write. And like most people don't actually have good API specs. And so like, if you think about how most parents, like I think like 90% of parents or something think their children are above average, when average is defined as like over the 50th percentile of child. Only 35% of API providers feel that their organization's API documentation is above average. So it could be that, they just are scapegoating their documentation writers. But it seems like what's probably true is that most people don't actually care that much about their documentation. And as a result, it's not good. And so there are reasons for this. So you have tools that help you with recording and sharing what you're doing with your APIs, but like no one's like, this is what's actually going on with your system. And there are libraries, there are specialized frameworks that like auto-generate API specs, but you have to write annotations, you have to buy into them. Like bottom line is you actually have to care about API specs. Like I said before, most people don't really care about specs because they're not like the cool part of the system. When you build something, the cool part is like the part that actually does something, not the part where you describe what it's going to do, but you don't know how you're going to build it yet. And like, like it's like specs are something previously that people thought of as something you write beforehand that is going to be kind of out of date, that very few people are going to read or care about. And that like is not what you're going to get the big bucks for. And so like that, I would say like, that's not how we want to think about specs. And I'll talk about how I think people should be thinking about specs. And so our challenge was, well, can we automatically model API behavior with as little developer effort as possible? Can we like automatically generate the specs? So instead of thinking about specs as like the unsexy thing you write beforehand, think about it as like a model of what the system is actually doing that we can communicate back to the developer, that we can communicate across developers, that is like actually tied to the code. And like the spec language just happens to be something that humans understand. Like this is how we're communicating it, but it's like a completely different use of specs, if that makes sense. And can we somehow automatically generate those without the developer needing to write any annotations, use any special libraries, or do anything different than what they're already doing? And so what we realized was, so the whole field I come from, the reason I showed you all those like things that probably were not relevant to you and, made no sense is because I wanted to convey that I come from a world where we have techniques and we have things, you don't have to understand any of these words either, but we have things like invariant generation. Variant generation is actually pretty cool. So, there's, like something you can do with it is you basically like, you just watch a program run automatically and then you learn stuff about it. And so there's like a lot of pretty good anomaly detection you can do if you do this stuff. You can detect like your access policies all through invariant generation. So you just say like, okay, watch the program run, see like who has access here, who doesn't have access. You can like learn all kinds of stuff. And like I'm happy to talk more about this later if this is something you're interested in. But that's like a pretty cool thing, but no one knows about it because it's like not really used most places. And then there's like example driven program synthesis, which all that is like you give a bunch of examples, and you could like, automatically figure out like the program that will do those examples. Type inference, so like automatically figuring out types and data formats. Trace-based analysis, like analyzing not like a program, but like traces of program behavior, which API traffic is exactly that. API-based fuzzing, which like you probably heard of if you work with API testing or API scanning. Automated testing, which is just the generalization of that. Well, there's basically like all these techniques that have been done before for, I would say, much more complicated things. Like a full-on Java program is way more complicated than an API. Like no one has like really looked at applying this stuff to APIs before we started going at it. And we were just like, well, APIs are actually like way simple compared to some of this harder stuff, and it's way useful if we can apply some of these techniques. And so that's essentially what we've been doing. So we've been taking these techniques, trying to automatically characterize API behavior and present the result in the form of specs, and then that's our foothold in mapping out the API graph. And so I'll tell you what we've been doing at Akita. But like I said, this is not a vendor pitch. This is like I'm just presenting this as like the instantiation of like everything I'm talking about. So what we're doing is we're helping you get a handle on your API graph. So we're helping you see what's going on with your web apps by dynamically modeling API behavior. No code or config changes necessary. So we're like a network sniffer, like Wireshark or something. We watch your API behavior, but unlike other things that just like tell you like this is what the API did, we try to infer structure onto it. So we auto-generate an API spec. So anyone can look at that spec and they're like, okay, yeah, that makes sense. That's what my API did. And then because we have such a nice structured way of describing API behavior, we can help improve code quality, reduce security vulnerabilities, because we can do regressions on those now. So we give you regressions on your API endpoints. We give you regressions at the API field level. And eventually we want to give you regressions on like, this is how your data is flowing across all of your APIs. And then the other part of it that we're doing is we think that the reason APIs are hard is not just because there's one of them, but because there's a lot of them. And so we watch web traffic not just one place at a time, but like, we try to connect up all of the web traffic and the flow of data across them eventually. And I'll talk a little bit about how we do that. And so I will just give a quick demo because like, you could be like, all right, you can say all these things, but this sounds like magic to me. Because like, I've never, I'll believe it when I see it. And so I'm going to show you how we watch API traffic and automatically generate an API spec. And then how you can use Akita to analyze your endpoints to see both like what your API spec is doing and what's going out from under it. Oh no, this my machine with my Discord has gone dark. Hold on. I won't know what emojis you send. And then how to detect potential API issues on every pull request. So something that we think we're potentially very useful for is security reviews and like, security, like shifting the security scanning left onto the pull request. And so I would love to get your feedback on this stuff. And so for a little bit of additional context, Akita has been around only since 2018. So we're very early. We're in a private beta. And I'd love to whoever is getting involved in us now has a major influence in shaping the direction of the product. And so if this is something you're interested in, I'd love to talk to you. But oh no, the whole computer restarted with the Discord. All right. So Kyle, if there are people with questions, feel free to tell me, because that other machine is restarting.
Yep. I'll let you know as they come in.
Okay, cool. Thank you. Oh no. I knew I shouldn't have unplugged it. All right, cool. So I'm just going to do a demo real quick, and then people can ask questions. Phew. All right, guys, it's back up. Don't worry. It's there. Cool. So what I'm first going to do is just show the Akita agent listening to some API traffic and generating a dynamic model of the API, which will manifest as a spec. So I'm going to throw up a Docker container real quick. And this is just a standard test container. It's called Akibox because it's a mini file sharing system. We named it after Dropbox. And so one way to run Akita is by running an agent alongside that just listens and watches all the traffic going to Akibox. There's another way to run Akita, which is generate a HAR file, an HTML archive file, and we can process that as well. And so I'm going to just make a few curl requests, essentially, that generate network traffic. And then we are ready to generate an API spec. So let's go over here. And so I won't be one of those people who are like, this is not an API spec. You think this is an API spec, but it's really an API behavioral model. But that is kind of what it is. And so what we did was we watched API traffic, and we structured the API traffic into the form of, here are your endpoints, here's what's going on at the endpoints, and you can navigate it. And so at a high level, this looks like just like any regular API spec that someone might write. I'm going to get in here and show you what we start inferring and how this starts differing from like a normal spec that you might write or even capture using another kind of tool. So here we have this special Akita tag that we stuffed into the spec. And this is a little JSON thing that says, for formats, we have this RFC 5322 email format. And so one thing Akita does is it does this inference. So part of the model that Akita builds is not just like, what are the endpoints, what are the types, but what are the specific data formats that we saw. And so this I think is really exciting because, first of all, because we have the structure of the spec, we're actually able to get pretty high precision on the data formats. Like, we're not just matching, but we're kind of like comparing this to like other times we saw this in this location. Whenever there are differences now, we can also detect regressions. But this is just the beginning of a lot of other things we can detect on the API. So the next thing we're working on is implicit API contracts. So if you have a certain country code, what does that mean about the relationship between that country code field and other fields? Does it mean that your other values have to be in a certain range? That that certain arguments for one field map to ranges and other arguments, and if you actually go outside of that range, that's like dangerous in some way. And so that's another example of something we can do. And in the limit, where we're headed towards is being able to detect contracts across your API calls. So if you call one API function, does it always have to feed the argument into the next function in a certain way? And so so this is why I like this. We are generating an API spec, but I really call this generating API models because they're really like pretty rich ways of taking API traffic, figuring out what it did, and then conveying that back to you in the form of a navigable spec. But it's there's a lot we can build on top of this. And thank you, Chopper BZ, for saying this looks promising. We agree, and we'd love your help on making it more promising. And so this is one part of it, and we show you not just what comes in, but what went out. So if you remember for here, we specified port 8080 as, this is the port that my service operates on. We also show you here are other ports that we saw you talking to and data that we saw go out across there. And then what you could do is you could create a service for that. You could analyze that one as well. And this is how this kind of discovery is how we see you build up the API graph. And then right now, we just threw up some insights to see who would care about what. But, we can tell you the specific kind of data types we saw. We can summarize sensitive data formats. We can tell you where we saw different data formats. And so maybe there's some kind of bug there. There's a lot of reporting we can do on what we saw. And something that we're currently working on actually is building up the command line part of this generation more so that you can configure, like, these are the data types I care about. This is the post-processing I care about, etc. And so that's the first part. The second part is, how do we use this to catch changes on every pull request now? So this is just Visual Studio, and I've made a Converge B-Sides demo branch. What I'm going to do, so this is AkiBox again, our old friend. I am going to uncomment a call to a new endpoint API register phone. I'm going to uncomment curl requests that calls that register phone endpoint. And then I'm going to make a pull request adding phone number endpoint and show you the GitHub comment that we automatically generate. That summarizes there's a new data type and there's a new endpoint. And from what we've heard from a lot of security people, that something like this could be very helpful for keeping an eye on the system, because if you don't know exactly what is wrong in general, you can at least keep an eye on what's wrong that's new. And so this is going to take a couple of minutes, because essentially what's happening here is this is integrated with Circle CI. So this is like very left shifted. And this is running. So when the Circle CI tests run, Akita watches those tests, generates a model for the new thing, compares it to a model from the old thing. So I'll show you really quickly. So if we look at AkiBox here, you can mark anything as a stable, and then you can actually merge and diff your specs too, as another thing. But what this is doing is it's merging against your latest stable spec, and then it'll tell you everything that's new. And so since this takes 1 minute, I will pause and see if there are questions or comments, or if people just want to send emojis to assert their presence.
So currently there's no questions yet.
Okay, cool. Yeah, and something else about Akita is people are like, well, do I run this in test? Do I run this in prod? So we're actually this is a pretty thin agent. Like, all you have to do is install the Akita agent and then just run it. And so we can actually run in anywhere. Like, anywhere you can run an agent, where that agent can watch your traffic, you can run it. And actually I will show you our docs, which anybody can check out. But there's also even, you don't even need to run an agent. You can also use a HAR file to generate specs from any website or any proxy tool as well. And so cool, this is ready now. We can stop awkwardly waiting for it. But here, this is like a pretty preliminary version of the GitHub comment. We're still like very much working on this. This is a work in progress, but we tell you, okay, this is the spec we generated. This is the baseline. There was one endpoint added, the register phone endpoint. These were the endpoints that were changed. Something I'm pointing out here is that we do path compression. So if we see many things, many parts of the same path that have different values, we'll say, well, okay, that's an argument in the API spec. And then there's a new data format added, which is the US phone number. Cool. And Chopper BZ says the proxy would help for analyzing or enumerating on an app. Yeah. So we didn't realize this at first because we initially just got the har file path for debugging. Because something else about Akita that I'll point out is we don't actually look at any of your sensitive data. So like how we run is we watch your network traffic, we observe it. We only send metadata about the requests and responses back to ourselves. So for a time we needed to debug somehow because like we don't see enough to debug like our user stuff enough. So we asked them, hey, can you send us some har files for debugging? And that led down to the path of like, well, we can just straight up generate specs from those har files too. And that unlocked a whole path where you can just like run run on a website. You can run on you can run using like the Charles proxy or something like that, and then you can just send us the har file and we'll generate you like a full-on spec, and you can diff those specs, you can merge those specs, you can do everything you can do with a spec in Akita you can do with the har file. Cool. So yeah, so I only have 2 more slides, so we can just, I guess, well, I only have 2 more slides in 6 minutes. So whatever time we have left, we can just hang out. But yeah, like I mentioned, Akita works by watching your API traffic. We only send witnesses back to ourselves. We've been in the process of figuring out actually how to push more functionality into the CLI and actually like make the source available for some of the CLI so people can either configure it or at least see like exactly we're not doing any kind of sketchy stuff with your data. And yeah, otherwise, it's a pretty simple thing that we do on your side, and then we do all the fancy stuff for post-processing on our side. Cool. So I know this is like probably a different talk than what you're used to, and also like the things I'm saying are probably weirder. So I made a couple of points about what to take away, and actually I'd love your feedback on like, are these the things you took away or is it different things? But I think one thing is a lot of people are like, oh, I've been trying to use static analysis or network analysis to solve this and this problem, and so they're like, wow, I didn't realize that I should stop expecting them to solve these problems for me, that there's actually these other problems that are unsolvable by them that are my problems. And so I think understanding the limits of these analysis tools is like a one potential good takeaway. Another one is there's actually a lot you can expect. So I think that I really liked when Jedi to me said, we hire pen testers to do all of our APIs, and they found a lot of stuff. I think that it's super cool that's the result you have. I think that if you are hiring people to do something, like there's like tools that I believe, like I think this kind of tool could really enhance a pen tester, for instance. Like if you show a pen tester, hey, like this is what's going on with your systems. And this is how they're fitting together. Like a pen tester, you can imagine, is even more effective if they get this map. And so there's so the reason I like want to be like, hey guys, even if you don't use what we're doing, there's just a lot more you can ask of automation at the API level. That's one other takeaway I would like for you to have. And then the other thing is, this is we're Akita. We're going after mapping out the APIs. We want to give you the API graph. We want to give you all this analysis that lets you catch breaking changes, and we're at the very beginning, so our tool is pretty early, and like we got here, we even this far we got only because a lot of people chipped in and gave us feedback, tried out our stuff, kicked the tires. And so yeah, we'd love for you to spread the word, come help us make Akita better. And if you're interested, you can go to akitasoftware.com and sign up for our private beta. And if you put a note that like you came to this talk, I'll just let you on. But yeah, we'd love to get your feedback, your help. And even if it's just like, hey, this is how you're telling the story about how it's useful, and I think that it's actually useful for this very specific thing. And if you said that, people would show up who are the right people. Like even that feedback is really helpful to us. So yeah, thanks guys. There are all these responses.
We'll probably have to move the questions over to the chat channel so we can set up for the 5 o'clock. But thank you very much for speaking. That was, and for me, like I have a very minimal use of APIs, and you reminded me how much of my programming that I did do was not even close enough to what I should be doing. So
Yeah,
thank
like
you.
so admittedly, like I was not using so many, like I've never used like 10,000 APIs. And so the more I've gone into this space, I was like, whoa, this is, this is so interesting. I did not know this is how the world is working.
Yeah.
Yeah.
Well, thank you again, and thanks for coming out to Converge and B-Sides.
Yeah. Thank you.